Problem number 54. Again, where is it increasing, decreasing, concave up, concave down, minimums, maximums for this trig function right here? And the interval is from 0 to 2 pi. So to begin with, the first derivative. So the derivative of sine is cosine. And the derivative of cosine is negative sine. So its negative is actually going to cancel out this negative, and it's going to say plus sine of x. Now there's no place where these functions are undefined, so we just need to find out where the derivative equals 0. So when does cosine plus sine equal 0? And then to solve this trig equation, what I'm going to do is take one of them and move to the other side. So subtract sine x from both sides. The next thing is, I'm going to divide both sides by cosine. Because for one thing, that's going to simplify the right side and just leave a 1. And the other thing is, on the left side, sine divided by cosine equals tangent. So that simplifies the problem. It just says negative tangent of x equals 1. Then you could multiply by a negative 1 or divide by a negative 1. And it's saying, when does tangent equal negative 1? For that, we could use tangent inverse. So what is tangent inverse of negative 1? And then it says negative 0.8785. So I could find out, is that pi over something by going divide that by pi, then go to math and change that to a fraction. So it's negative 1/4 of pi, or negative pi over 4. But according to this, we don't want negative answers, we want positive answers. So if you were to look at the tangent graph, it would look like this. There's an asymptote at pi over 2 and at negative pi over 2. And then where is it equal to? So this is, where's the tangent graph equal to a negative 1? So if you go across, then this is at negative pi over 4. But we want positive answers. So you could draw another branch of tangent. And if you follow the negative 1 across, there's going to be another answer right here. So then, where is that answer? Well, the period of tangent is pi. So if you need to get from one answer to another, then you just add pi. And if you need another answer, you just add pi again. So the next solution would be negative pi over 4 plus pi. So this is basically saying you've got a whole pi and somebody ate 1/4 of it. How much is left? That would be 3/4 of a pi. Now, in order to get another solution, add pi again. So we found this solution. Now to find the next one, add pi again. So the next one is going to be 3/4 of a pi plus a whole pi. So you could get a common denominator by multiplying the top and bottom by 4. And then this will be 4 pi over 4 plus 3 of them is 7 pi over 4. All right, so the important numbers that we got for the first derivative are, at least in this interval, 3/4 of pi, and then also 7 pi over 4. And then let's take a look at the graph and see if that looks right. So y equals the original function, sine of x minus cosine of x. I have the window set up from 0 to 2 pi. And it looks like there's one answer right there where the derivative equals 0 and one right there. Let's see if I got it right. So 3 pi over 4, yes, that's actually a maximum. So there's a maximum point at 2.356, comma 1.414. And then for the minimum point, that should be the 7 pi over 4. So the minimum is at 5.498, comma, negative 1.414. So the minimum, the maximum, we still need to do increasing and decreasing. So in here, it's increasing. So that's from 0 until we get to the 3/4 pi. So from 0 to 3 pi over 4. Now at 3 pi over 4, that's a maximum value, so it's neither increasing or decreasing. So this should be a round parenthesis. But we did not get the answer x equals 0. So that means that as it passed through where x equals 0, it was increasing that whole time. Or if I widen the window a little bit, then you could see as it passed through where x equals 0, it was increasing. So that means that this should be a square bracket. Now also increasing is this last bit from 7 pi over 4 until the end 2 pi. So union from 7 pi over 4 to 2 pi. And what happened at 0 is also happening here at 2 pi. It's increasing as it goes through there, so this is a square bracket. And then for decreasing, so that's just when it goes from the top to the bottom. So that is from 3 pi over 4 to 7 pi over 4. We're now done with the first derivative. In order to find concave up and concave down, we need the second derivative. So first, I get a new piece of paper, and then I write down the first derivative, and then we're ready to do the second derivative. So for the second derivative, the derivative of cosine is negative sine. The derivative of sine is cosine. And then set that equal to 0. And the work is going to be very similar to the last time when we did the first derivative equals 0. Take this, move it to the other side. It'll actually become a positive sine x. And just like last time, divide both sides by cosine. So once again, we get tangent. This time it equals a positive 1 instead of a negative 1. And if you find tangent inverse of 1, divide that by pi, change it to a fraction. That's 1/4 of pi. So x equals pi over 4. And like we did with the last one, since the period of tangent is pi, you could take this one and add on pi, and then we would get another answer. So common denominator is going to be 4. So that would be 4 pi over 4 plus 1 more is 5 pi over 4. So we have two answers. Now if you add on another pi, that means you'd add on another 4, so that would be 9 pi over 4. And the interval stops at 2 pi, 9 pi over 4, that's too much. So we only have these two. So where is it concave up and where is it concave down? So if I type in the pi divided by 4, so this part is concave up, and then it changes to concave down, and then at 5 pi divided by 4, And this last part in here is concave up. So it goes concave up to concave down to concave up. So concave up is this left part, which would start at 0 and then go until pi over 4. And then also this last part on the right, which goes from 5 pi over 4 to 2 pi. And then for concave down, that's the middle. So this part is concave down, that's the middle. So that's between pi over 4 and 5 pi over 4.